Hi, hello. Good morning to all. Hi, hello. Good morning to all. Now I would like to tell you about the measurement of pressure by using U-Tuube manometer. The main objective of this session is to measure and calculate the pressure by using U-Tuube manometer, to measure and calculate the local atmospheric pressure, and some basic calculation using Labview virtual instrument. As we know, the basics of this U-Tuube manometer is, here you are observing, if you are observing here, just a second, yes, here you are observing the U-Tuube manometer. The input signal is the pressure signal and it is exposed to atmospheric pressure. As you know already the basics of this U-Tuube, I am not going into detail of the U-Tuube. Whenever you are giving a pressure signal here, automatically the level of the liquid inside this tube will changes. Accordingly, the height of the liquid column is changes. Then we can easily find out the pressure of the system or pressure of the signal by using the height. For this, the basic formula used in the system is PA, which is the atmospheric pressure, plus G by GC H into rho m is equal to P plus G by GC H into PF, where I have clearly mentioned H is the differential height, the density of the fluid transmitting pressure is PF, and the density of the manometer fluid is PM, and where APA is the atmospheric pressure. So one has to satisfy this equation, which is very simple. Now we will go and solve this simple equation by using our Labview. So the problem of fifth experiment is like this. A U-Tuube manometer, an U-Tuube manometer employs a special oil having specific gravity of 0.2 of the manometer fluid. So once it is there, we need to add the special oil as like this. Here the given data, the data whatever they have given, let's write here. This specific gravity I can take specific gravity of the oil is 0.82 of the manometer fluid. One side of the manometer is open to local atmospheric pressure, which is having, say, I can take the local atmospheric pressure PA is equal to 29.3 mm of Hg, and the difference in the column height H is equal to, I can take 0.2 centimeters or plus or minus 1, and the temperature when exposed to air, the temperature is T is equal to 25 degrees centigrade. We need to find out the pressure in Pascal. Hence, as we know from this formula, the gravity of the standard, since they have taken acceleration standard gravity, the gravity of the earth is 9.87, whereas GC we have taken the reference as 1.0, and the H we have taken 0.2, where the pressure PA they have given in terms of mm of Hg. We need to convert mm of Hg into Pascal. So the formula for conversion of mm of Hg into Pascal is some x pascals is equal to 9.922 into 10 to the power of 4 into the input of mm, say x or y, divided by 29.3 pascals. So if we want to convert mm of Hg to pascals, we should use this formula: P, pressure in PA in pascals. And another term we need to calculate is, we need to convert this temperature degree centigrade into Kelvin. We know already how to change it. If you add with 273, it will automatically convert into Kelvin. So the specific gravity, that's PM, can be easily find out by using PM is equal to specific gravity of the fluid into specific gravity of the water. And PF can be find out by P by RT, where P is the pressure in pascals, R and T is the temperature, where we can find out. So by using these formulas, formula 1, formula 2 and formula 3, formula 4, and this final formula, formula 5, we need to develop these 5 formulas in the Labview. Now let's open the Labview first. As you know, Labview is open. In this Labview, you need to take 3 formulas: P minus PA is equal to G by GC H into PM minus PF, where first of all we need to convert the pressure of mm of Hg into Pascal. In this reason, let's go to right click, numeric, and you take a vertical fill. In this vertical fill, you take it as an controller, and whenever you change this one, automatically the pressure changes. So I am writing here as pressure in mm of Hg. Now I should make whatever the pressure I am giving, I should multiply with the 9.922 10 to the power of 4. Hence I will right click on the block diagram panel, I will go to numeric, and I will take the numeric constant. This numeric constant will be double 9.922 into 10 to the power of 4. I can write 99220. I should multiply these two, hence again I should go for right numeric, take the multiply factor and add a wired connection for these two. Once I will take the wired connection, after this I should divide the value with the 29.3. Hence I should again right click, numeric, take the divide operator, place it here, connect it here, and you need to connect, right click, go to numeric, take one numeric point and change it as 29.3 and give it to the divide. So by this you will get the pressure. If you give input pressure in mm of Hg, you will get output in pascals. Hence you take a numeric indicator and you write in as pressure in pascals. So take this and write it, pressure in pascals you got. After this you are also need to take the temperature. So the pressure you may take from 0 to 100. For this reason you change, right click here, go to properties. After going to properties, you can change the scale as 0 to 100, that is up to you. And even you can change the color inside it by using very different color as you require. After this you need to take the temperature input in degree centigrade to Kelvin. Again the same formula we need to add. So the input temperature, go to right click, numeric, go to thermometer, this rename as input temperature. Input temperature possibly maybe 0 to 100. I have taken that. Input temperature you should change it to control. This input temperature you should, in degree centigrade, you should convert into Kelvin. again right click, go to additional operator and add this with the 273, right click, numeric, and add 273, then you will get output in Kelvin. Hence I can click on the pascals. I am pressing Ctrl and dragging it, and I am connecting it and renaming it as temperature in Kelvin. So if you give input temperature, the output will be in Kelvin. Bring here. So if you want to have a clarity, just enlarge it. Further having a clarity, right click on it, visible items, go to digital display. You will find the digital display here. In the similar fashion, right click on it, visible items, digital display, you will get digital display as well here. Once you are finding out the pressure in pascals and you have find out the temperature in Kelvin, now it's time to find out the specific gravity of the given fluid. So the specific gravity of the given fluid is 0.82. So we should multiply with our given value of water, specific gravity of water. Just for this sake, I have already developed a block diagram. I am showing you here. Means you need to go as per the formulas. Once you go as per the formulas, you will find all things easily. I have already developed this file. Since I am opening that one for your purpose, U-Tuube manometer, and I am opening block diagram. Hence, see here, I am highlighting this part. This part is highlighted as this part. You are giving input pressure in mm, you are getting output pressure in pascals. In the same way, you are giving input temperature, you are getting output temperature in Kelvin. Once you got these two parts, now it's time to do some algebraic manipulations. The density of the given fluid, as you know already that the specific gravity of the fluid they have given as 0.82. So that is the reason why you are taking density as again a variable. You can observe in your block diagram as like this, the density of the given fluid. This is the density of the given fluid, the same thing. Now you will go back, and if you see side by side, now after this the final pressure can be calculated as by using the formula P minus PA is equal to P minus PA is equal to G by GC into H PM minus PF. PF again you are calculating as PF, that can be easily calculated with the help of the formula. PM you are also calculating with the help of the formula. PM you have already calculated by using 0.82 into density of the water. Here that is the one. PF you are calculating here. PF is equal to P by RT. Whatever the pressure you are getting, that the pressure you have taken here, by R. R is 283 at the temperature whatever you have given, P by RT. So finally you have got the density of the air. So again these are the simple algebraic calculations. This is the one I have taken to merge the waveform. Whatever the pressure I am getting, I want to see in terms of waveform. That is the reason why I have taken this one. So this is I have not given a detailed one because this is as your assignment. I am leaving it to you. You please practice and and report me the waveforms. For your purpose I am running this program, just have a look at it. So I'm keeping this program in while loop. I have already told how to use while loop in my last class. Now see, once I run this program, if I'll give my pressure input as 29.3 mm of Hg and my temperature as 25 degrees centigrade, I have automatically got pressure in Pascal, I got automatically Kelvin in output, and I am giving density of the fluid 0.82, and the density of the fluid we have got here, and the final pressure of the system is 100,820 pascals, and the density of the air is 1.17. Even if you can change here, automatically the waveforms will change. So you need to give me observations by changing the input temperature. You please